All right. Good evening, everyone. Thank you all for coming. My name is Todd Brous. I'm your host for this evening, and I'm here with Susan Schultz and Ashley Wilson. And we would like to welcome everyone to HBAP Startups. So let's get started. For those of you who are new to the Startups group, we have a few announcements that we do at the beginning of each meeting, and we'll do some short networking breakout rooms, and then we'll come back together for our main event. And first off is our mission. We are here to help foster and fortify an innovation and entrepreneur community coming out of the Harvard Business Analytics program. And our goal is to provide our members with the tools, knowledge, leadership, and confidence necessary to create and grow their businesses from the ground up. Susan.
Yeah, so there's plenty of ways that you can understand what we're doing, learn more about what we're doing, and keep up to date on upcoming things. So you can see it here. We've got a website, we've got a YouTube channel, we've got a newsletter, we have a Slack channel, which is entrepreneurship. And of course, this isn't just for HBAPers anymore. So if you've got a friend or a colleague that you think might be interested in hearing some of our speakers and our topics, definitely invite them. And then just a reminder that unless the speaker says otherwise, we do post the recordings publicly on our YouTube channel. Mm-hmm. And so again, just a reminder, because people come here with their ideas and things they're worried about, and speakers, their journey and their companies, all of those kinds of things. So we want to create an inclusive environment for that and a safe place for people to talk about ideas. So we are really focused on collaboration, confidentiality, and trust. And all rights are reserved by the presenter unless they tell us otherwise. And then, of course, everybody's complying with the honor code of HBAP. And then, again, always we abide by the Francis Fry feedback approach, which is for every one piece of tart feedback, we do 4 pieces of positive feedback because that works better. Or you can just even skip the tart feedback and do only positive feedback. And then just a reminder, no personal or recordings of our sessions because that violates our privacy code and our speakers' requests for confidentiality. So if that happens, we will need to take you out of the meeting. And then as always, if there are any concerns of conflict of interest, confidentiality, any of that, just reach out to me, to Todd, to Ashley, and we'll help you figure it out. So we've got some cool stuff coming up in the next month. So today we were supposed to have the other co-founder of Featrix.ai, but he is, like many people these days, is pretty under the weather. And so the other co-founder of this company is Pawel Zimoch. Did I say that right, Pawel?
Yes.
Okay, awesome. Who's going to talk to us about this really cool company that makes creating AI solutions 10 times faster than what people do right now. And then coming up, we have Karen Nolan, who is the CEO and co-founder of Mappy, where they create customized exploration locations for ski slopes and other vacation venues. And then on February 14th, we're going to have a building GPTs workshops because that's a new feature that's now available where you can make your own GPT for your own very customized needs. And then on February 21st, we have Peter Shao, who is the CEO of Immortal Studios, and he is using AI to pretty much transform how he does art and photography and film and all of those kinds of things. And then on later on in month of February and in March, we're going to have Andy Spielberg, who was supposed to be with us postdoc in Grid, talking about his AI research and his company. And he also got violently ill. So we think we're going to get him back in February 28th.
All right, so let's do some breakout rooms. Uh, Give me a second, and I'm going to open all the rooms, and I'll see you folks in about 5-6 minutes. I'm going to pause recording. All right. I hope everyone had fun in your breakout rooms. Just a little reminder, at the end, please do stick around for overtime. Also, when you leave Zoom this evening, by the time we're done, please, you should see a little pop-up window in your web browser. Please fill out that survey. We're data analytics people. We love data. It helps us. It keeps us happy. So please keep us happy. Fill out data. Fill out surveys. We love it. And just again, a reminder, the recordings will be made public. And please do stick around for some overtime, which will not be recorded. All right. Now it is my honor to introduce tonight's speaker, Pawel Zimoch. I'm sure I'm screwing up your pronunciation of your name. I'm so sorry. Pawel, it is a pleasure to bring you here tonight. Pawel is a serial entrepreneur, machine learning engineer, and a software developer. He's got over 13 years of experience writing software for research and commercial applications, and 5 years of experience building customer-facing products. He specializes in designing and training fancy neural networks and building and deploying massive distributed machine learning systems. When he was first bitten by the entrepreneurship bug, he created and ran some fun web apps. And currently, he's the CTO and co-founder of Featrix. He's on a mission to make accurate, high-quality data modeling available to everyone on any data. He has engineering degrees from Harvard and MIT, where he studied fluid mechanics, thermodynamics, and information theory. And again, he is the head of AI at Featrix. So now, without further ado, as is our custom at HBAP Startups, if we could please briefly unmute ourselves, and let's give a warm round of applause to Pawel Zimoch. Thank you so much. Let me stop sharing.
All right, thank you very much for the introduction. I'll just share my screen to show some of the slides. All right, can everybody see my screen? All right, I'd like to start by wishing the Mac a happy birthday. As some of you may know, today is the 40th anniversary of Steve Jobs' announcement of the original Macintosh. So I just wanted to acknowledge the special date today. My name is Pawel. I'm the CTO at Featrix. At Featrix, our mission is to make accurate, high-quality analytics and machine learning available to anyone on any data, and I'll go into much more detail on what that actually means in this presentation. I have over 10 years of experience working in artificial intelligence and machine learning, building all kinds of models for science research and for commercial products. And I like to think of myself as a software engineer and developer. I actually have experience running a solo bootstrap business and building a web app from scratch. So this is not my first rodeo trying to build a business. All right, let's jump right into Featrix. So at Featrix, this is sort of what we do in a nutshell. We take data, we specialize in taking data and feeding it into AI, machine learning, and analytics systems. And so here, AI, ML, analytics, I'm being a little bit loose as to what actually we do. We've heard people sort of referring to the same things by different names. So essentially pulling out useful information, learning interesting things from your data is what we're here to help you with. It's difficult to talk about AI without acknowledging LLMs. I'm sure everybody here has heard and played with them quite a bit. And LLMs are great. They're trained on all of the information in the world, and they are a fantastic user interface. I really enjoy using ChatGPT, for example, to help me with all kinds of different tasks. But they have their limitations when it comes to analytics. When you really need to crunch some numbers and come up with some predictions or recommendations, or do anything that requires crunching significant amounts of data, LLMs might not be the best tool, at least not in the form they exist today. Meanwhile, they're also responsible for an incoming huge wave of data. It's a sort of common saying that 90% of enterprise data is unstructured and is about to be unlocked by LLMs. So something that LLMs do very well is they are able to ingest a lot of unstructured data and turn it into something that's more usable. And we believe that one of the main things that LLMs do with unstructured data will be to turn it into structured data of some sort. There will be ingest pipelines for PDFs, for invoices, for all kinds of things that output maybe some action, maybe some unstructured data as well, but some part of the output will be structured data. And that means that the demand for analytics, for predictive machine learning, and for automation in general will keep going up. And in spite of that, what we see is that machine learning and artificial intelligence projects often, there's all kinds of problems. They don't live up to expectations. They take too long to get working. They blow through the budget, or they fail in production. And in most of the cases, this has to do with some problem with the data or the data pipeline. Some of the data is dirty or missing, and so the model cannot be trained. Disparate data sets are used in training and in production. There's distribution shift. Sometimes the schema changes upstream, and so on and so on and so forth. And the reason why projects are so sensitive to problems with data is that really dealing with data ingest into an AI product or an AI project accounts for the majority of the work. The data has to be explored. Sometimes exploratory data analysis plays a very important role. It has to be cleaned, deduped. It has to be turned into features that are appropriate for machine learning models. And then finally, it has to be encoded. Machine learning models typically require an input in the form of a string of numbers. So even strings are not something that ML models can deal with easily. Meanwhile, this is something that doesn't have a solution in the market right now. So there's a growing field of machine learning platforms, which are suites of tools designed to help running machine learning at scale easier. And so this typically comes under the term of ML ops. Some of you might have heard that. And this is a screenshot from one company that provides an ML ops product. And you can see what they view as being a part of their job, right? So there's reports, hyperparameter search, experiment tracking. There's a little bit of data set versioning. But what I'd like to bring your attention to is that data preparation is this little circle off to the right here that is outside of the purview of that product. And we believe that this is sort of not where the main problem is. Sort of the main problem really in running ML pipelines is with data preparation in the first place. And so what do customers do today when you have a project where you need to develop some predictions, you need to create recommendations, do any kind of machine learning task? You typically have to prepare the data manually. And at least the first stage of that is to give it to a machine learning engineer or a data scientist, and they have to spend a non-trivial amount of time preparing the data. They have to derive features from the data. They have to understand the data set. They have to understand its quirks. They have to understand where the data may have come from. They may have to deduplicate the data. They might have to normalize it. They might have to standardize the representation of time or other information, and so on and so on, and so forth. And we've talked to a number of people in the industry, and they keep telling us that this doesn't scale. This has been the case for many years, and the same kinds of problems people run into over and over and over again. It takes months to get a working machine learning project going. You can spend millions of dollars and not get a whole lot for it. So those are problems that have been around and keep persisting, even in this age of sort of AI being everywhere. And so at the heart, what Featrix does is it takes all this work and does it for you. and we do it with machine learning ourselves. So we take all this code that you would have to write, or a data analyst or scientist or a machine learning engineer would have to do, and they would have to know how to do it. So they would require expert knowledge. And we turn it into a series of API calls that take a handful of lines in your code, and you can get equivalent results for predictive tasks. So this is essentially what Featrix does. And the way we do it under the hood is that we can ingest multiple data sets, and we create a unified ingest pipeline for your AI using AI. And we do this with embeddings. You might have heard the term embeddings in the context of LLMs or retrieval augmented generation, which is a very popular technique these days. And what we do is we effectively train custom embeddings for your data, for your specifically tabular data, for your structured data sets. And what this does is it untangles your data. So it takes these tasks of exploration, cleaning, featurization, and encoding, and effectively performs all of them at once by looking at the data and building an internal statistical model for what the different relationships between parts of data are, and representing that information in the form of vectors, such that quote unquote similar pieces of data end up nearby in the resulting vector space. And this is sort of represented graphically by the sphere that you can see on the screen right now, where the data points representing different elements of data start in a scrambled state, and then through applying our algorithm, we see that essentially the data points corresponding to distinct parts of the data tend to sort of self-sort themselves into a structure that reflects what's actually in the data. And our goal and what we want to enable is for people, for developers, and for executives to be able to create predictions on all the data in the world, any data set, anywhere, in a way that's scalable, repeatable, and in a way that would eventually sort of allow you to bring your enterprise closer to sort of to be able to automate many more tasks and many more processes than currently possible. And so in a little bit more detail, how we work is we ingest the data, and we construct a custom contextual transformer model that creates a set of pre-trains a set of models that are able to represent your data as a set of numbers, which is exactly the format that machine learning models need for input. And so once we have this foundational model for your analytics purposes, you can then use that model to derive a large number of dependent models which are aimed at specific tasks, whether it's prediction, whether it's representation, and so on. So this foundation really acts as a base for your analytics purposes. And one advantage of this approach is that downstream models can be implemented in any platform. So we can build those models for you, or if you have already existing model pipelines, if you already know how to deploy and serve your own models, that's fine with us. The output we give you is just a very standardized representation in the form of vectors. And we believe, going back to LLMs, we believe that one of the ways in which data will be handled is ELLMTL, which is another acronym that we might need to learn in the near future, which is that the unstructured data will come in, they will be processed by LLMs. The LLMs will extract some subset of useful information from that data, and they will load it into sort of more traditional data stores, such as data warehouses or data lakes. And so I'd like to give you a couple of examples of how that works in practice, and the kinds of things that you can do once you have the sort of foundational model for your data, the sort of analytical foundational model for your data that Featrix can build. And one example is exploratory data analysis. We took a look at the Boston 311 data set, which is a publicly available data set in the city of Boston that contains records pertaining to non-emergency services that the city provides. So when there's when somebody forgets to put their trash in the street, or the truck forgets to pick it up, the city of Boston gets a call, and that call gets recorded in this data set. And so we looked at, and this data set is about 25 columns. It has a couple 100,000 records in it. So it's it's not big data, but it's a decent sized data set. And for the purposes of this analysis, we stripped out the geographic information from the data set. So if you go online and you look at the data set, there's actually latitude and longitude associated with each record. But here we stripped it out because we wanted to show that you can, even if that information wasn't there, you could pull out some interesting geography-related features from that data set. Now, this image shows the encodings, which are the representations you get for different police precincts in the city of Boston. So one of the columns in that data set records which police precinct at the given record is coming from. And here you can see a little map showing where the different precincts are located. And what we found after we trained our encodings is that when we encode the values of the individual precincts, and we represent similar vectors that are close together with yellow values, and vectors that are far apart, or they're pointing in different angles, we represent those with dark colors. We see that the actual geographic relationship between precincts is reflected in the data. So even if you didn't have any knowledge of the fact that this data relates to geography in some way, the encoding learns that from the data itself. So the statistical patterns in the data are such that different police precincts get encoded to a location in the embedding space that approximates their location in the city of Boston. So the police precincts that are close together, and those that are far apart are far apart. So this kind of approach can really help exploratory data analysis. Here's another example where we took a look at the encoding of the hour and the day of the week that a given ticket is created in. And so here we can look for clustering. We can see that rows correspond to days of the week, and the columns correspond to hours of the day. And we can immediately see that there's two big clusters present in this data set. One of them has to do with business hours, and the other one has to do with the weekends. And so right away, we see that there's some non-trivial structure in the relationship between these two values, right? And we didn't have to think about it ahead of time. It just sort of falls out of the automated analysis that the system performs. One of the more exciting things that you can do through this style of analysis is you can join data sets that don't necessarily have unique join keys. And this is a problem that many data scientists, data analysts run into, where you have to merge data from multiple disjoint systems, and you have to look for sort of unique join keys. And that's actually not very easy to come by unless the system was designed from the beginning for these two data sets to be joined. It can be very, very difficult to perform this kind of a task. And here I'd just like to demonstrate what happens when you try to use our system on a simple sort of contrived toy data set, just to make the example a little bit easier to digest. So here we have a data set that contains weights and heights of different kinds of pets, cats and dogs. So there's two groups of pets, one for cats and one for dogs. And let's say that this data set was collected by two interns working at a veterinary clinic, and they didn't really communicate with each other about this, and they forgot to put the name of the pet next to each record, or some unique identifier of the pet. And so one data set contains only the type of the pet and its height, and the other data set contains the height and the weight. And we would like to learn something about the relationship between pet type and its weight. And here, this is particularly difficult between height, which is the only column shared between these two data sets, is a real valued number. And so if there's any noise in the data, it will be impossible to join these two data sets. But if you apply Featrix system, you can look at the relationships between different pairs of variables, even if those variables or those columns are not in the same data set, because we create one model for all the data sets in a particular project. So if your project contains multiple data sets, we will create embeddings for all of them jointly. And so if they share a column, even if that column doesn't have exactly the same values, even if it can be used as a unique join key, if there's sufficient information, we can still reconstruct what the relationship between the variables that are not in the same data set is. So here we see the rows are the rows correspond to different types of pads, and columns correspond to different bins of the height. And we see that, here very clearly, the dogs are the taller animals. We can also create the same plot to see what the relationship between the height and the weight is. But what we can finally do is we can look at the relationship between the type and the weight, and we can see that here we sort of automatically get the relationship that dogs are not just the higher animals, they're also the heavier animals. And so this is a type of an automated analysis that makes your data very easily digestible by downstream systems. And finally, just to show you what we can do for data cleaning, I would like to show you a live data that we have on our website. You can go to Featrix.ai, and there's a link to demos. And these demos take the form of Colab notebooks. So this is something that you need to know a little bit of coding to really use. We're working on a self-serve web product that we hope to release pretty soon. So that is coming. For now, it takes the form of an API. And here I'd like to bring your attention to what happens when some information in the Boston 3-on-1 data set is what you would say denormalized. There's different values in this data set that mean the same thing, but take on different values. So in particular, wards are administrative regions within the city of Boston. And in this data set, the name of the ward, depending on which system originated a particular record, whether it was, say, an app used by a citizen or some sort of an internal system that a city employee might use, this information about the word comes encoded in 3 different ways. And this is something that would be very familiar to anybody who's worked with data. It can be 03, it can be just 3, or it can be the whole name spelled out, word 3. And again, we see that we are able to essentially automatically reconstruct the fact that all these 3 things mean the same thing, because you can see that this blob here represents the fact that all these 3 values get encoded to vectors that are very close together. And when I zoom out, and you can see this picture for all the words, you see that this kind of pattern follows through the whole data set. And there's some other sort of non-trivial patterns that you can see right away, a little bit of checkerboarding, again, having to do with which record came with which came from which system. So that's it for me. This is my email. I'd be happy to take any questions. I would love to hear about your stories working with data, working with maybe dirty data. I'm sure there are some horror stories out there. I really like hearing about them. The sort of problems that you run into, if you have any anecdotes about problems working with data, I'd love to catch up. And if you have something that you'd like to work on together, I would love to hear about that as well.
Pawel, thank you. This was really impressive. This is what you guys are working on is just mind-blowing. You definitely have my data scientist really excited right now. I know there was a question earlier, a hand raised from Gary, and I'm going to cold call him because I didn't prep him for this. But if he's there, Gary, if you're around, I know you had a question. Awesome.
Pawel, you talked about colors, and you told us to recognize, but I don't know what the colors mean. And you didn't say yellow is a big thing. You mentioned references to other things, but you didn't say where significant colors were.
All right, my apologies. So here, in all these plots, yellow means that the vector corresponding here, let's say to 22 inches, and the vector corresponding to dog are very close together. They're aligned.
Right.
And so that yellow means that the dot product between these two vectors is close to 1. Dark purple or dark blue means that the dot product between these two vectors is close to -1.
Okay.
And the intermediate colors are values in between.
Yeah. So that was like, as you were going through it, and Todd, like, he was right to tell me to shut up. But I was like, okay, but what am I looking at? Because I see yellow, I see purple, I see what the visuals are doing, but I don't know what to look at, and I don't know what to interpret. Is basically, yeah.
So here, let's take this plot here. Can you see my mouse?
Yes, I can see. I can see that.
Great.
Yes.
All right. So in this plot where we say look at the similarity between type
and weight. Yep.
Type and height. So here, each pet type gets its own what we call embedding, right? So you can represent each of these dog types as a vector, and then here we represent each height, each value of that scalar as a vector as well. So this is actually a continuous function, but here we just show it for some values just to make the plot easier. So what we see that the value dog is much more closely associated with large values of height than with low values. So from this image, you see dog is associated with tall heights, and cat is associated with short heights. On this plot, you see that height and weight are correlated with one another strongly, right? And so here, just because of how these images typically work, the value is increasing downwards. So just note that, right? So as you increase in height from 17 to 24 inches, you also tend to increase in weight from 9 to 40 pounds. And so here, this image shows you right away that these two values are pretty highly correlated.
Sure.
Because where one shows up, the other one tends to show up in similar cases. And so here, this plot here shows that cats are associated with low weights. And this is the information that wasn't in the data set, right? So this is effectively what comes out from the algorithm itself. Are you perhaps familiar with word embeddings? Is that something that you may have heard of? Before LLMs came around, word embeddings were a pretty big thing.
No, I personally no.
I see.
No.
So maybe in that case, I can sort of explain it by just referring to just sort of in more general terms. Before LLMs came along, you could essentially create a numerical representation for each word in a sentence or in language by looking at what other words it tends to be nearby. Right, with the assumption that words that tend to appear nearby tend to mean something similar, or they appear in sort of in similar settings. And therefore, the representation of that word was highly indicative of its meaning. And if you looked for words that had nearby representations, you tended to find, say, synonyms, words that tend to appear in similar statistical settings. And so here, in more detail, if you wanted to interpret these graphs, you could say that the entity dog in this data set has similar statistical properties as the entity, 40 pounds. And so you can see the correlation here. I used the word correlation before, which I
understand what that is.
I don't mean this in the correlation in the sense of linear relationship, I mean sort of mutual information, right? It shows
Sure.
you which values tend to be associated with one another.
But and my second question, the language behind all this, is it Python? Is it like what's the engine behind all this?
Yeah, we use a pretty standard set of ML tools, predominantly PyTorch, which is a Python library.
But sure.
And so, it's Python, but really under the hood, most of the work is being done by C++ and CUDA. That kind of forms the foundation of PyTorch.
Nice. No, thank you for this. But I was like, I liked everything, but colors was like, okay, explain the colors, because I understood what I was looking at, but I was like, what's significant and what really should I be looking at is what I was.
Thanks, Gary.
Thank you.
Mafe, you've got a question. And then
Yes,
I know you had a question in the chat, but I'm going to come to you next.
Hi, Pawel. I must have missed the legend of the colors, and so in this case, how come the numbers are inverted from 17 down, and doesn't that affect the scale when presenting the correlation on the y-axis? It shows 17 to like it's inverted, and so I thought I was just thinking that does it affect the correlation because of the scale of these numbers?
I see. So as far as this plot here is concerned, this was plotted using a pretty standard a standard Python library for showing images and not graphs, because we internally rendered this as an image, and so we're using an image-specific library. And the fact that the scale is pointing downwards is just an artifact of that. This was a plot we originally created for sort of internal purposes. Then we realized it might be helpful to show it in presentations. And so perhaps that's that's the reason why it really should be sort of flipped vertically. As to whether the scaling affects the correlation, so that's actually one of the things that we take care of for you, which is standardizing the data. In machine learning systems, especially those based on gradient descent, it's very important to encode the data such that the gradient descent algorithm takes more or less similar steps in every dimension to avoid issues with optimization and sort of running into instabilities and such things. So in order to have a successful model, you need to normalize all of the features, all of the information going in, whether they're scalars or timestamps or discrete variables. You have to find a way of representing them. And so we handle that up front. And then we sort of, we do that transformation back when we need to show the data in sort of its native scale, so to speak. So we rescale the data, and the correlation as understood colloquially is not affected. If you were to look at this image and then compute the correlation coefficient, sort of the traditional correlation coefficient, then you would naturally get a different value based on how the variables were scaled. But you can think of the transformation that we performed is performed in a space where that scale, where all the data has already been rescaled to an appropriate range of values. So the training happens in rescaled data space.
Thank you.
Thanks, Mafe. Olga, you had a question in the Zoom chat, so I'm going to call on you, and then I'm going to go to Susan and then Victor. But I'm going to Olga.
And I guess since I asked that question, I have a couple more. So thank you, Pawel. So we know a little bit about data joining, and we've done multiple exercises joining different sets of data, which I assume is joined based on some common denominator. If I'm wrong, feel free to correct me. What would be special about this product that makes that auto join result produce the outcome? Like what is different? Is it faster? Is it more accurate? You know, what is different about it? And that's the first part of the question. The second part is, while comparing cats and dogs heights is kind of interesting experiment, what would be the practical application for this model that you can implement immediately, or who would be your immediate customer if you had to like sell this product? Where do you see the low-hanging fruit?
Yeah. So to answer your first question, the unique part of this is that you don't have to have exactly matching keys to perform the join. So a typical situation is when you have two data sets that contain some personal information about your clients, but they come from two different data stores. And the question, you might have multiple customers named James Smith, right? And so in each of these data sets, James Smith, the same person, gets a different unique ID. Maybe, you connected the address in one of them, maybe not. And so when you go and you want to do an analysis on this kind of data, you have to join those two data sets, right? And going just by the name might be very difficult. And the same situation has to do with timestamps. If the shared information is a scalar, then it's even more difficult. And what this product allows you to do is it allows you to do the join statistically. So without having to worry, is there an exact match or not? And the practical application that we're pretty excited about is being able to enrich your analyses with additional data much more easily. So imagine that one of those data sets that you want to join is your internal data set, and the other data set is, say, an external data set. So you're selling some product, and you know where the customer is when they're buying that product, and you would like to, say, investigate, or maybe that your product is seasonal and the weather affects sales, and you would like to build that model. Well, now you have to build a model that joins each sale with the weather that existed at that sale, right? But maybe the address you have for the user is incomplete. And so in that case, if the weather data set and your internal data set have information about where the user lives, their location, you might do that. You might use that information to effectively join those two data sets statistically and be able to say that, hey, this user might be more likely to buy, or this user tends to buy our flip-flops where, when it's cold outside because they're thinking about their summer vacation, right? So those are the kinds of things that you might be able to do. Essentially bring more. So what this does is it allows you to bring more data together. Almost any analytical model is made better by having access to more data, and this is a way of making that easier.
That's awesome. Thank you.
Mm-hmm.
Thanks, Olga. And we'll go to Susan, and then we'll do Victor, and then DJ.
Yeah, this is so cool, Pawel. It's wonderful. So I have a bunch of questions, but I'm just going to ask kind of one of them right now. And it's a different set of questions. So pretty much everybody on this phone call is either thinking about a startup, doing a startup, or working to change and use more analytics and artificial intelligence if they work for a larger company. So we're always super interested in anybody that's takes a kind of brand new idea and then creates a product and that appears to be lovely and has customers and all that. So my question to you is, tell us a little bit about your founder journey, especially the stuff where in hindsight you say, well, darn it, I wish I had known that before I moved through whatever painful piece it was.
I think the biggest lesson in my entrepreneurship journey came from my sort of previous foray into entrepreneurship, which was the web app that I mentioned. And I learned during that project, I learned that I had an entirely wrong mental model of what it means to run a business. Especially as an engineer, a person coming from a computer science engineering background. I was pretty sure that engineering wasn't going to be all I did, obviously, that I wasn't that naive. But still, when I was thinking about what it means to be running a business, I was thinking about the code mostly. What does the code need to do? And, the very humbling experience is that the appropriate, or at least in my learning, the appropriate mental model for an early stage startup is just a funnel. Where do you find your clients? Who are they? What do they need to do? That has to be the first thing you think about when you wake up, and the last thing you think about when you go to bed. What the product does, or maybe how it's executed, is, I don't want to say it doesn't matter, but I think it matters a lot less than an average engineer might think. I remember when I first started working on the app, I was very proud of how well executed it was, and that it was crash free. It never broke. But I significantly underestimated the difficulty of actually connecting with the users. And so that was, going into Featrix, I partnered with Mitch primarily because I understood that Mitch was much better at that part of running a business than I was. I can contribute my technical skills, and I think I'm more sensitive than an average engineer to sort of the needs of the business. Engineering, even the AI, we're an AI-centric company, but even in our case, AI is just a means to an end, right? And the end is to solve real problems for real people. And just the centrality of that, it sounds pretty trivial when you speak about it after the fact. But it seems like a lesson that you have to learn on your own skin at some point. I've learned, I've read all the books. I knew I thought I knew what I was doing going in, and yet without really being in the moment and having to make these decisions, it's very difficult to see what really matters. And so so now I think of what I did before sort of as a trial run, sort of a way to do, a way to do to make all the mistakes fairly early on. And so, I can't say I haven't made any mistakes while working on Featrix, but hopefully they're different mistakes.
Cool, thanks. And I've got more, but let's go to, I think it's Victor next, right?
We'll come back, Susan. Yeah, definitely. Victor and then DJ.
Yes, thank you, Pawel. This is quite interesting what you built. I wanted to step back in perspective because I'm not sure I understand the business model. Mm-hmm. Are you selling or licensing a DIY tool for your clients, or are you receiving their data, processing it, and sending back the output of the tool and maybe some insights?
So the product is a service, or is going to be a service. We're still working on that part of it. It's going to be a software service that you can sign up for online, send us your data, and then we will process that data for you and make an endpoint available to you where you can query the vector space effectively. We will also make it possible for you to essentially create a function that maps the vectors onto something that's useful to you, some sort of a prediction, for example. And so we see this as data comes in, the data that you have, the whole point is you don't have to worry too much about what that data looks like, whether it's normalized and all that. And then we process all of that data at the same time and create essentially a service for you to be able to give us more of that kind of data, and we give it something that's useful for analytics purposes. So you can think of it as sort of like an auto cleaning service where we also make it possible for you to train downstream models. But right now, at this minute, the product requires a little bit of coding expertise to use. There's an API that you can check out on our website. Does that answer your question?
Yes, it does. And I have a follow-up. You said something earlier that led me to think about as you gain client and project experience and basically data set experience with unique data sets coming in from your clients, you'll have at least a knowledge base. If you're not involved in the applications, you'll have a knowledge base of data sets that might be let's say, enriching external data sets that any given user might benefit from. And you would have that insight that they wouldn't, right? So they're sending you what they have. They think they know that what they have is the best grouping of data for their purpose, but you may have an insight from your knowledge base that could expand or even explode the strength of their models in their business. So if that's a fact, do you see the possibility of an advisory service in the future along those lines?
So something that we like to do is to process publicly available data and make it trivially easy to extend your data sets or your models with publicly available data through the auto join feature. Whether that comes through service or not, I think is a question to be answered. We'd certainly love to find a method to do it automatically, essentially do the work for you and say, hey, here's a data set that you might be able to use as well.
Right, becoming a little bit more engaged in their actual subject matter project. I think that's an interesting opportunity. It may not be your core right now, but
yeah, especially we're at such an early stage that right now we recognize that a new tool like that may require a little bit of hand-holding early on, and we're very happy to do that. We are again early enough that this is possible. It's not from a point of view of building a business. That's not necessarily the desired end goal, but it's definitely a way to get there.
Sure. Well, it's looking great. Congratulations to you and your partner and your team, and thanks for presenting to us tonight.
Thank you.
Thanks, Victor. DJ, and then Pravmeet.
Yeah, I'll just keep my questions short because part of it was already raised by Victor. I was just curious as a follow-up to that. I mean, is that a continuous processing data model once you kind of plug in and then it starts bringing in the data? Is that like a continuous flow, or what is the mechanism that you've built in?
So we are working on making it into a full stream. Right now, it operates primarily in batch mode, but there's nothing, there's nothing in principle that prevents it from operating on a streaming basis. And in fact, understanding how the underlying data changes over time, and so on, that there's a whole range of features that we think are unlocked once you have such a vectorized representation of your data.
Yeah, and I mean, it's an amazing utility that you built it, because when I was at Salesforce, we built CDP and I was a product manager for it. But that first part that you just mentioned in terms of transformation of data, that was led to an admin as a UI interface through a drag and drop model for them to basically either take the first party model that we had as a basis, or customers could come in and completely design the custom model to feed the data into the platform. And I think just seeing the AI transformation is very useful here. It just kind of takes away all that nitty-gritty and complex away from having a person manually design it, So it brings in scale, efficiency, and speed also at the same time.
Agreed.
Thanks, DJ. Meet.
Thank you, Todd. Thank you, Paul, for sharing your journey. The one thing that caught my eye, and I know this product is cool, it's great, wonderful colors, everything else we talked about. But my question is, the thing that struck me was when you said you need to understand your customer more than what your product is doing. And that's my takeaway as an entrepreneur is like, you might have the greatest product, but if the customer doesn't have a need for it, it doesn't mean anything. So is there any specific industry that you think will help more, or are you going after a specific industry type? Why I ask that is because healthcare and financial services are heavily regulated. There's lots of data privacy, data security concerns around that. So which particular one, and what? I have some other questions, so let's answer that one first.
Yeah, that's a great question. So we are targeting not the services that you mentioned. So
Okay.
so right now we are focused on data that doesn't have such privacy connotations. Obviously, that's something that we'd like to be able to handle later. Right now, one vertical that we have some traction in is sales. So salespeople or sales teams tend to use data from multiple systems that might be difficult to join, might be difficult to handle. And there's all kinds of predictive tasks that they like to be able to do. Whom should I call next? Whom should I offer a promotion to? Who should be, who's about to churn? And that data typically has fewer regulations and restrictions associated with it, and it tends to be pretty valuable. So, or at least those kinds of insights tend to be pretty valuable. So that's a good vertical to try out our solution in. But generally speaking, I think from the point of view of the product, we're trying to build a product that can handle any vertical. And the person we're targeting is a developer or a data scientist who essentially wears more than one hat, or maybe a larger team where there's a single person who wears the data science or machine learning hat. And they need to handle a lot of data, and they need to spend their time on actually understanding the statistics of the data and not handling, string normalization, those kinds of things. So we're targeting, the individual developer / machine learning person who needs to take care of all of that. I think the product would be suitable for bigger teams as well. But in terms of the product market fit, that's what we're focusing on right now.
Cool. Thank you for sharing that. Now, is there in your model, confidence level that they're providing, that you guys are providing for the cleanup? Like how closely matched are these? In your cats and dogs example, I was just thinking, if it's a Chihuahua, it's probably shorter than a cat, and it probably weighs less than a cat, and that would be an anomaly in there.
So that's a great point. I think we're cognizant of the fact that the product might seem like a bit of a black box because it's based on transformers neural networks, right? So I don't think that we could explain exactly why the value is what the output value is what it is anymore that LLM creators can explain why the next word is X and not Y. So explainability at that level would be very difficult to achieve. However, what we could do, and what we're planning on doing in the product, and we do on the back end, is to essentially test the self-consistency of the model, right? So the model is trained on a particular set of pretext tasks, as these sort of pre-trained models typically are. And so those are tasks that are derived from the data set itself. And what we could do is we can measure how well the model does on the task that it's given to it. And we can measure that on the training set, we can measure that on the validation set, and the test set as well. And we can report these numbers, and we can report them, per task. And these, I don't necessarily want to go into detail here, but these tasks bear, some relationship to the data itself. They're fairly easy to interpret. So, we can't provide the explainability behind every single prediction, although, that's something we love to be able to do. But we can provide a sense of confidence that the model isn't doing something weird. And one of the features that we build into the product is that the answer can be unknown. If you've trained the data, one of the biggest problems with AI models in general, but LLMs in particular, is hallucinations. Most people would have heard of hallucinations these days. And analytical models, they've been subject to this problem for a very, very long time. If you feed it something that it hasn't seen in training, how do you know that it's going to generalize as well? How do you know that it's not going to just make something up? And so a degree of safety that we provided for this is that if you feed it data that's significantly different from the data that it was trained on, it'll just return unknown. It'll just say, I don't know.
No, cool. Thank you. I mean, if you have the confidence level and the transparency, I think that helps the individual data scientist rather than, I mean, you don't have to explain it. That's their job to look at it and analyze it and take it further. So this first step of cleanup should certainly help them. One last question. Sorry, Susan. Sorry, Gary. Any kind of biases that you've observed that have crept into the data? From what I understand, that the beautiful color coding thing you showed was more like, hey, this is how it's correlated, this is how we are joining it. But have you observed any biases in your journey so far?
The short answer is no. But I think the fuller answer is that I don't think we've engaged with data sets that this would have been a critical concern for. So it's like I said, we're focused on data sets that are more straightforward to deal with from the regulatory and sort of non-ML perspectives. So we haven't really hit that road, hit that particular problem yet.
Thank you for sharing. On to you, Susan.
Thanks, Pramit. Susan, and then we'll go to Gary.
Yeah. So I have many more questions, but I'm only going to ask two right now. They're more kind of about the business and where you are. So my first question is, what's your pricing right now? What's your pricing model that you're either using or thinking about using, and why? And then I'll tell you my second question, which is, what's your biggest worry? I get asked that all the time from my advisors for my startups, and then there's evidently a right answer and a wrong answer. So I'm really curious to hear what are you most worried about right now? So pricing and worry.
Yeah. So pricing is tricky, and I don't think we have it fully figured out. I think ultimately we would like to have a usage-based pricing model. This is just because it aligns incentives for the user and the producer over the long term, right? Ideally, it would be tied to value, not just usage, but actual value that you're delivering. Whether it's, I think it's quite difficult to quantify value in machine learning in the first place, so that might be a little bit too difficult, but usage, and in some cases at least, it's a good proxy for that. In the short term, I think, especially for a startup in an early stage like ours, I think a subscription-based pricing model that's sort of tiered according to usage, but doesn't quite scale directly, is probably easier for users to understand. You know, this is a new product. It has features that potential buyers might not be familiar with, and just adding more decisions they need to make and worry about, you know, how much this is going to cost, like that's just not helpful right now. And I think in early stages, there's a premium to having a very simple pricing structure and just working with your early customers to really learn what you know, what the right pricing model really is. So it's a bit of a non-answer answer, but that's that's kind of where we are at this point.
Cool.
And as to your second question, what am I most worried about? I think the question is always, do I know enough about how people would use this? Can I create a story? Could I tell a story about a user who comes into work and really sort of what do they do, and where does Featrix fit into their work? You know, what would a typical day look like for a person using Featrix? What kind of problems might they run into? And so that's, you know, that I think that's the primary concern. You know, if Featrix fails at this point, which I certainly hope does not happen, it won't be because the product doesn't work. It'll be because we haven't understood our market well enough. So I think that's really the primary concern.
Cool. Thanks.
Thanks, Susan. Gary, and then we'll go to Craig.
Yeah, I think he just answered it. Explainability, training, and ownership. He just said it all. I think he did. So explainability of the model, how you train the model, and ownership. Do you own the output of it? And then how people use it is. But I think from what you just told Susan, I think you answered all that. So I don't feel like I need, unless you disagree. Yeah, Pawel, but unless you disagree and don't hear me. But
Sorry, would you mind repeating? I'm not sure I understood.
yeah, so from what Susan said, explainability of the model and what you do, how you train the model is interesting.
Mhm.
And do you own the output, the result? And I think you said to Susan that I think you answered it, but
should we move
yeah.
on, Gary?
Yeah, I think we should move on.
All right, thanks, Gary. Craig.
Pawel, thanks for the presentation. For my takeaways, I think you sort of said it early in your slides that a really big problem is that data preparation. Absolutely agree with that, nodding that, but bringing data sets together that, you know, co-joining those to get make more sense of the problem we're trying to solve. So are you so I could see this being super helpful in like prototyping, like prototyping, getting MVP very, very quickly. I'm trying to understand if you, from a scalability perspective, where if you're doing you're building like transforming the data, you're building your model, and then obviously you want to deploy and you want to scale it into your business. Are you trying to? I'm just trying to figure out where that transition works. Are you looking at potentially replacing elements of, like, you know, like a SageMaker or something like that, or Azure if you're going into like a Microsoft environment? Can you just explain a little bit about how that would work, just so I'm a little more clear?
Yeah, so I think, you know, we are certainly targeting for operating at the scale of at enterprise scale. right? That's what we're shooting for. This is an enterprise product, and we're going for that kind of scale. At this point, and this sort of relates to the earlier question about streaming versus batch. Currently we process data sets that I would describe as useful size. It's not quite big data. We're not talking about terabytes here.
Yeah.
We are talking about millions of rows, tens of columns, that kind of stuff. So big enough to be useful, but small enough that it fits on a single machine, which I guess if whether or not it fits on a single machine is the measuring stick for whether it's big data science or not, then it's not. It's still, we're focusing primarily on saving people time right now.
Yeah, I could see that. I could absolutely see that, because I'm just thinking of an example, something that we're trying to solve, and we want to bring in a number of different data sets. And so that data preparation, you're right, it can take a long time, a massive amount of time, and you start 80%, doing that versus the 20% building, really building the model. I absolutely believe that I'm not sure there's a lot of solutions that solve for that problem well, that I've seen. So that's why I do think that is solving an important problem. But I'm trying to, one of the things we'll be thinking for you will be, okay, how would I, if you're working with, say, enterprise businesses, they're using, Azure, AWS, Google Cloud, and so on and so forth, and deploying, across geographies and so on and so forth. So how can your tool, if you will, your service, your platform, work with that as well, right? So in other words, so you can scale the solution. Once I co-join the data, I've got this, and it's now continuously feeding potentially, right? Because especially if you're doing real-time data reporting and you're trying to do predictions and analytics for customers on that, I think factoring it in for some of those applications will be potentially quite important to get any penetration in the market.
Yeah, we've architected the system so that it can run, on our infrastructure, in your own infrastructure as an independent service. So whether you're on Azure or AWS or GCP, we can set that up.
Yeah, but definitely, anyways, I can see the problem you're trying to solve. I'm a lot more clear about that now. And there is, as I say, these tools are needed. So I think you're onto something.
Thank you.
Thanks, Craig. DJ.
Yeah, following up to what just Craig was saying, the other aspect that I can see is the plugin aspect. So you could even provide me a plugin. So if my platform as a CDP, as I was saying, is you're solving this challenge for the data scientists up front. But if I could use Featrix plugin just as a button, and if I click on that button, then the button would actually create a visual image knowing all the data sources that I'm trying to utilize, right? And it would give me a recommendation. So even just as a plugin model, which is recommending me or guiding me to a particular schema in terms of all those data sources would be just another form of a service that you can provide, because it just depends. Like every customer is pretty much protective of their data set. So they wouldn't like their data sources to go on someone else's service. They would still like to keep a complete control of it, right? And that's where your service as a plugin with just a button recommending me and mimicking what that could be would be such a powerful tool also at the same time. And then coming back to what Prambit was saying is, I felt like it's like being coming from the product management aspect part of it, we never felt like, though it's a data science problem, we never felt like it was the engineers who kind of owned it, because at the end of the day, the input always came from the business side, in terms of how it's affecting, in terms of marketing or the campaigns that we needed to run, and what kind of data sources or data that we were looking for all that input always came from the business side, right? So in terms of the attribution model, if you can bring in the business value to it in terms of utilization, then it actually helps me reduce my cost of ownership, looking at the data sources and the utilization in terms of what it's contributing to the revenue model, right? And if I know that I have basically drawn a data source which is helping me enhance my model. Say, let's say I brought in two data sources, data source 1 and data source B, but B is the one who's actually looking at the attribution model, is contributing to the enrichment part of everything. And what that tells me is over a period of time, A is basically useless. So I'm not only consuming a lot of data storage because of the data that I'm sucking in, but that enrichment is not actually creating any value for my business. So if that information gets tied in, then it becomes a very powerful business tool for the business users to actually use it, right? Because the creation aspect is always underneath the covers.
Yeah, that's very helpful. Thank you.
Thanks, DJ. Jian.
Oh, thank you, Todd, and thank you, Pawel. My question is about your AI system. Was that built internally or external? Then yours has like, because you're talking about the multiple data setting that put it together through your working pipe, and then you're able to categorize them in each group. It's like clean up the data and do the analysis, and then select what kind of a cluster will be useful for your business, right? So my question is that set up internally, like internal AI, or your focus on like a general AI for the whole HBAP businesses?
So that is all internal. So we, run our own. I mean, we obviously rent infrastructure from, cloud providers.
Yeah.
But other than that, we run our own machines, our own training. Sort of the system is internal. We use industry standard tools, PyTorch is an example. So we didn't reinvent the wheel where it didn't need to be reinvented, so to speak. But yeah, we have our own internal system.
Okay, so you're talking about huge data, like 90% of the data from outside of your collective data set. And then you're talking about using public data. Are those data, how are you sure those data are quality, high quality or useful or relative? I mean, relevant with your subject.
Yeah. So it so I think we cannot make up information that isn't in the data set.
Yeah.
But we are pretty good at extracting whatever information there is. So if the data set is noisy, we will do our best to reduce that noise. And so I think that the value for us is, it's very easy to get going. Right now, you have to put in, significant amount of work to get any ML model to work. And after that, you have to iterate quite a bit. Our goal is to make it possible to train in like a really good quality ML model in an afternoon at most, with very little work.
Are you talking about you able to use your device or your strategy, you're able to mimic the data that I needed or ideal data for me in order to find the other data to match or to do the AI whatever analysis is going to be or going to need it?
So at this point, we're not that far. So
Okay.
at this point, we don't yet have the functionality where you give us data and we tell you, oh, here's the 15 public data sources that you might be interested in. We don't have that at this point, but it is something that I think we're interested in. Yeah, and as you know, if the information isn't there, if the data is so noisy,
Yeah.
that just the information sort of scientifically isn't there, then we can't do anything about that. But our goal is to sort of reduce the noise as much as possible by using the statistical patterns that we can pull out from the data.
So with your strategy, there is some limited, not suiting for any kind of data set. Some data set maybe work out, maybe some not.
Well, I think if you feed a collection of say data that's so noisy that it's very difficult to make heads or tails.
Okay.
And then I think we Featrix could still be helpful to the extent that it can pull out the information that is there, but it might not meet your business goals, right? And because the information just isn't in the data set.
Right. Okay, thank you.
Thanks, Gian. Susan, I think we got the last word out of Susan. You get the last words.
I'm going to three-peat. So here we go, Pawel. So one of my questions is, how are you building and maintaining your moat to prevent poaching of your idea, especially, if somebody decides to have it be open source? That's my first question. And then the second one is, how are you finding customers? What process are you doing to find customers?
Mm-hmm. So to answer your first question, part of the moat is technological. So we've built a model and a system that sort of does something that's difficult to replicate, and we have a couple of patents pending on that as well. So there's a degree of IP protection. But we live in a world where things move so fast that you can't really bank on that to be a lasting source of differentiation. And so it's certainly helpful at the beginning when we enter the market, just because there's nobody else who does this. But over time, surely somebody else will come along. And I think ultimately the moat comes from putting in the work that machines can't do. You have to do something that is difficult or expensive or takes a very long time to replicate. And understanding the market, and I think understanding exactly who your user is and what they're using your product for, that I think that is an underappreciated source of moat. I think there's been cases where just understanding who your market is sufficient to get you ahead. And over time, we want to build a system that sort of runs most, if not all, analytics in the enterprise, right? And data systems tend to be pretty sticky. Once you have something that works, once you have a data flow that works, that delivers value, that tends to be pretty difficult to replace. So I think the data systems in general tend to have their own moats once they're in use.
Yeah, makes total sense. Yeah, because it's difficult, and it just takes time to go to a different system. So if you're happy with it, it's very sticky. Yeah, especially with enterprise. Okay, and then the second one, how are you finding and vetting your customers?
Yeah. So I think we're still at a stage where they say do things that don't scale. My co-founder likes to joke that our target market is people within a 2-hour drive of Boston because we're based in Boston. And you know, even in the age of Zoom, you know, it still pays to go and meet in person and to hear what somebody's problems are. So we are pretty heavily leveraging our personal networks. Events like this one, frankly, we are always looking to meet people who have problems with data, who are looking to do interesting things with data.
So, oh, Susan, did you want to follow up? Sorry.
No, just cool. Thanks.
I'm looking at the time. Do you have time for one more question?
Yes. Yeah.
All right. So Grażyna, and then we'll end it with Grażyna.
Hi, Pavel. I have to say, I wish I had your product 5 years ago because it would have saved so much time, especially being able to join data sources that don't have that common denominator. So thank you for bringing that product to life. But my question is a little bit different. So thinking about sales data and what you predict, perhaps customers might churn or something else related to sales or customers. My question is, does your product now work with other applications, something like Salesforce or anything where, let's say you predicted these customers will churn and then automatically it communicates to certain application, sends customers an email of, let's say, you know, dear customer, we want to offer you something special, whether an email, a note, or automated phone call, whatever it may be, to take that automation further of what your system predicted. So any thoughts of what applications your tool will work with? Thanks.
Yeah, that's all of that is on our roadmap. You know, we don't have any direct integrations right now, but Salesforce is one that sort of is first on our list. And you know what you described, which is making automation easier, that is what we're after. You know, and again, that's not in the product right now, but the ability to set up a workflow based on automated predictions and then actions being taken based on that. That is what we think technology like this can unlock, right? Because when you know, I think maybe more broadly, if I may, the problem with many data science and machine learning projects right now is that they tend to be dependent on humans throughout their entire life cycle. You know, the person who builds that model, the data scientist who builds that 20-page notebook that I showed on one of the slides, that person tends to have to be involved in the project throughout its entire life. You know, and if that person leaves your company, that's, you know, that could be pretty difficult. And so, you know, setting those things up, creating these kinds of automations tends to move at human scale. Making any changes to this kind of a system tends to move at human scale, which is weeks. And we'd like to be able to reduce that to, you know, seconds, maybe minutes, ultimately. You know, and we think that really sort of you know, tackling that data ingest problem is really the problem. And once that problem is solved, then I think a lot of other sort of like once we're through that door, there's a big green field or a big blue ocean on the other side of it.
And do you have a timeline of when you plan to solve that problem? Cross that ocean, Atlantic Ocean?
You know, I think our timeline is flexible. We could, you know, if we found a customer who found it particularly urgent, we could accelerate that. I think right now, none of our current clients have that as a priority. But, you know, one of the advantages of being a smaller business that's in early stages is we can, you know, the roadmap is negotiable at this point. But yeah, like that's definitely something we are interested in doing at some point, and exactly when, you know, we can be flexible on that.
And just very short question, but just to get a sense for us upcoming entrepreneurs. So how big is your company? How many people?
So we are about 6 people right now, depending on how you count, because we are we have a few independent contractors. You know, there's only 2 people who are, you know, employees of the company. Everybody else works on a contracting basis. So you know, it's still pretty early. But we're, you know, we're as the business grows, the team will grow as well.
I like the way you count.
Thank you, Pawel, for sharing, and please let us know how we can help.
Great, thank you.
Thanks, Regina. Susan.
Yeah, so yes, I am. Okay, yeah. So Pawel, thank you so much. It's really cool. I can see in the chat that some people want to talk to you further about usage, and I do as well. I was just we can use what you're doing in our startup too. So I think there's going to be several people reaching out to you and to talk further.
Great. Please, you know, this is my email. Feel free to reach out. We're very open to continuing the discussion. You know, whether it's to just learn about your problem, you know, hear you out, and just sort of hear about the horror stories, or, you know, talk about specific engagements. We're very happy to do all of that.
Awesome. Awesome. Well, you have a wonderful product. And would you be up for coming back and talking to us at a future date as well, an update, but also maybe looking at some other things like how early you started on looking at product market fit, things like that. That'd be super cool as well. Are you up for that?
Yes, I'd be happy to do that.
All right, great.
Awesome. So I'm going to stop recording, but before we do end it, please do stick around for some overtime. And a quick little reminder, next week is Karen Nolan, the CEO and co-founder of Mappy. February 14th, which I know is Valentine's Day. So for those of you like me who don't have anything else to do, come hang out with us because we'll be giving a workshop on building GPTs and some, you know, prompting techniques. And then February 21st, Peter Shio, the CEO of Immortal Studios, will be joining us for a nice little presentation. Thank you all for coming. I'm going to stop recording and we will stick around for some overtime.